this circle, first you should write, there are 4 components in proving section. First of all, you should write data. Thereafter, construction. If you need any construction, necessary construction, you should write what did you do. And thereafter, the proving part, finally, the results. First, data was denoted. The R is the midpoint of chord PQ, so that means R will bisect the entire chord. And O is the center of the circle. So a straight line which is connecting midpoint of the chord and straight line OR, that is the one which is connecting center of the circle O and midpoint of the chord R. Okay. Thereafter, the question was, if ROQ is 45, if ROQ, that particular angle is 45, you should prove RQ equals to OR. Okay, RQ equals to OR. So ROQ means, for that we need to do some construction. Okay, after connecting this, ROQ is this one. This angle was denoted as 45 degrees. And one more detail, we know that since the midpoint of the chord and center of the circle are connected by a straight line which is bisecting the chord, that means here also we will have a perpendicular relationship. We know that one from chord theorem. We know this relationship as well. So by using this, we are going to prove RQ equals to OR. For that, no need to think about this triangle because we need to deal with this triangle only. No, I will explain this one using simple method. The construction was, we don't need this one. Construction. Join OQ. Join OQ. Here in the triangle, you can see this is 90 degrees. How this one is 90 degrees? You should write that with reasons. Proof ORQ. ORQ, that is 90 degrees. Because according to the chord theorem, no need to write the chord theorem again. You can write the reason as chord theorem. That is enough. Chord theorem. And thereafter, we know one more data. This angle as 45. ROQ. ROQ is 45 degrees. That means, what would be the remaining angle? If this is 90, this is 45. So OQ are also 45. Why? Because summation of interior angles of a triangle is 180. No, this is 90, this is 45. So therefore, the remaining angle OQR is 45. How we found this one? Here you should write interior angles of triangle. Interior angles of triangle. By using that theorem, we just found OQR as 45. Now look at this. This is 45. This angle also 45. It says if the opposite angles are equal, the sides which are located opposite to the equal angles are also equal. Other than that, this is an isosceles triangle. In isosceles triangle only, we will have two equal angles. So you should write ORQ is an isosceles triangle. Is an isosceles triangle. Isosceles triangle means what would be the remaining equal sides? RO. RQ, I will write RQ, that should be equals to OR. That's all. Okay, that's all. Nothing else to write. It is the compact answer. First you should write the data, then you need any necessary construction, just do that. Then proof. Here we don't need, no need to prove these two triangles congruence because there is nothing related with this triangle. No, we have one thing here, another thing here. Definitely we need to incorporate both triangles. In this case, everything are consist in a single triangle. So we can do that like this. ORQ 90 Chord theorem and ROQ 45 data. OQR, we found this one as 45. This is ORQ is an isosceles triangle. In isosceles triangle, this side would be equals to this side because the opposite angles are same. Now that's how we proved RQ equals to OR. There are several other methods also possible to show the relationship, but this is kind of compact answer.